Here's problem 1035. A celestial object called a pulsar emits its light in short bursts that are synchronized with its rotation. A pulsar in the Crab Nebula is rotating at the rate of 30 revolutions per second. What is the maximum radius of the pulsar if no part of the surface can move faster than the speed of light? So let's imagine we have this object, and let's say it's considered to be spherical in shape, and it's rotating around very quickly like this with some angular velocity omega. Now we're told that the frequency that it's putting out is 30 revolutions per second. So its angular frequency, which is 2 pi times the frequency, will be 2 pi radians per revolution times 30 revolutions per second. So that will give us 60 pi radians per second, or if we multiply that out, 188.5 radians per second for the angular velocity. Now if we're considering a point that is moving the furthest distance around every revolution, that would be a point right on the equator of the spherical object. So it's moving around a full circumference every rotation, and hence the velocity, the linear velocity of that point, is going to be equal to the angular velocity times the radius to that point, the radius of the pulsar itself. So the radius of the pulsar is going to equal the linear velocity of that point divided by the angular velocity. Well, if we say that the maximum velocity that can be is the speed of light, then this is going to be the speed of light divided by the angular velocity of the pulsar. And that's going to be 3 times 10 to the 8 meters per second divided by 188.5 radians per second. And this will give us the radius of the pulsar in meters. That is 1.59 times 10 to the 6 meters will be the radius, the maximum possible radius of the pulsar. Otherwise the speed would be too fast. Well, that happens to be less than 1/3 the size of the Earth. If we had the Earth in comparison with this pulsar, it would be this size, like this, would be the size of the Earth in comparison with the pulsar. So the pulsar is less than 1/3 the radius of the Earth, the one that exists at the center of the Crab Nebula.